We've been talking about perimeter and area, so let's apply it now to the coordinate plane. We're going to have to use skills that we've been using all year, so let's refresh our memories. So we need to draw and classify a polygon with the vertices of E, F, G, and H. Then we're going to find the perimeter and area of the polygon. So hopefully you remember that the first thing we need to do is to plot these points. So if we have E at -1, -1, F is at 2, -2, G is at -1, -4, and H is at -4, -3. And when we connect our dots, we see we have a quadrilateral. And you may be thinking, hey, that's a parallelogram. But how do we show that it's a parallelogram? Well, the key to a parallelogram is that the opposite sides are parallel. So let's find the slopes of our sides. So the slope of EF, now remember E is -1, -1, F is 2, -2, G is -1, -4, and H is -4, -3. So the slope of EF, we have -2 minus -1 over 2 minus -1. So the slope of EF is -1/3. EF should be parallel to HG if it's a parallelogram. So go ahead and find the slope of HG. Both of them have a slope of -1/3, so EF and HG are parallel. But we need to make sure that the other two sides are parallel as well. So the slope of EH you get 2/3. So check to make sure that the slope of FG is 2/3 as well. We do get that they both have the same slope, so we know EH and FG are parallel. So this shows that we have a parallelogram. So now we need to find the perimeter and area. So to find the perimeter, we need to know the lengths of all the sides, which means we're going to have to use the distance formula. This is going to be the distance of EF. So when we remember our distance formula is x2 minus x1 squared plus y2 minus y1 squared, and here's E, x1, y1. Here is F, x2, y2. So now we can substitute in. Remember to include your square root. A lot of students are forgetting that, and it's messing you up in the end. Now since -2 minus a -1 is a -1, make sure to put -1 in parentheses. 3 squared is 9, -1 squared is a +1, So we get that EF is the square root of 10. Now to do the distance of FG. So now FG, we could leave F as x2, y2, and G becomes x1, y1. So when we substitute in, we get 9 plus 4, and when we add those, we get the square root of 13. So if we go back to our picture, we know that this is the square root of 10, which means the HG is the square root of 10, and that since FG is the square root of 13, we get that EH is also the square root of 13. So now if you're finding the perimeter, we have to add all of our sides. So the perimeter is the square root of 10 plus the square root of 10 plus the square root of 13 plus the square root of 13. Remember your rules about your radicals. We can combine square root of 10 and square root of 10 to give us 2 square roots of 10. And we can combine square root of 13 and square root of 13 to get 2 square roots of 13. This is our perimeter. Don't forget to put your units at the end. This is the exact answer. If it had said round to the nearest tenth, hundredth, or whatever, then you type it in the calculator and you get your approximation. But this is the exact perimeter for our parallelogram. So now let's think about the area. Well, if we go back to our picture, hopefully you see that if I were to separate this into 2 triangles, I know that the base of each triangle is 3. This blue line here is not the height of the parallelogram. We just divided the parallelogram into 2 triangles. From there, if we look at this triangle, we know the base is 3, and the height is right here from point H to the base, which is also 3. And let's get a different color, which is also 3. So to find the area of one triangle, it's 1/2 base times height, where we know that the base is 3 as well as the height. Now since we have 2 congruent triangles here, we're going to end up multiplying that area by 2. So if we go ahead and multiply by 2, we can simplify this, and we get that the area is 9 units squared for the parallelogram. So it is possible to use area of a triangle for a parallelogram instead of using base times height. You just have to decide when that would be a good time to do that. So jot in your notes about explaining why we did 2 triangles here versus trying to do the base and height of the parallelogram. When would be a good time to use 2 triangles versus base and height of a parallelogram? So now using the same points, E, F, G, and H, I want you to describe a different way to find the perimeter and area. I want you to write this down in your notes, and I want you to show the work to verify that you get the same answers that we got. This will be due at the beginning of class on either Monday or Tuesday. It will be a part of your daily grade for this unit. So make sure that you take the time to really think about another way that you could have done perimeter and area using these same coordinates. Now, looking at this figure here, you see that we have the same shapes. So how can you show that the area does not change when the pieces are rearranged? Hopefully you notice going from this polygon to the one on the right, they have rearranged the green and the blue triangles. But how can you show that the area does not change, even though there is a hole here? And why does it look like one has a larger area than the other? This will also be due at the beginning of class on either Monday or Tuesday, so make sure you have your explanations. If you have any questions, please make note of them and come in and see me so we can work on them together. I look forward to seeing you in class, and let's think about your answers.